not stopped me. That has not stopped me. Today, we're going to talk about one of my favorite math subjects, bases. Like decimal and hexadecimal, binary, ternary. There are a lot of different things you can do with bases. So, we're going to do some of that stuff. Well, I'm just going to showcase it, but here we go. So first, just a quick reminder on what is a base. A quick reminder on what is a base. What base is, let's say you have base B. That means that the first column is B to the 0, B to the 1, and then B squared, B cubed, and so on. So, yeah. So let's take decimal for example, the one we humans use all the time for nearly everything, mainly math. So B 0, 10 to the 0th, 1. B to the 1, 10, 100, 1,000. If you want to write 42, 4, 2. We don't have a single symbol for 42. We just 4 times 10 times 2 times 1 plus 2 times 1. And that's how you do it. But there are other bases too, like let's say binary. We actually need a lot of columns for this. Let's say we want to write 42. That's 1, 0, 1, 0, 1. That's 1 times 2 to the 0th plus 1 times 2 squared plus 1 times 2 to the 5th. That's 32 plus 4 plus 1. Well, 42 plus 8 plus 1. 32 plus 8 times 1. Sorry about that. And that is 32 plus 9, 42. It's very complicated. There are a lot of bases. But today I'm going to be talking about things you can do. First is, so we got that out of the way. First, we have positional versus non-positional. Positional versus non-positional. So positional means, let's take decimal for another example. Now for the heck of it, let's use ternary because that's one that humans aren't familiar with. Most humans. So that would be 3, or I should probably write that better. I should probably draw that better. We have 3 to 0th, 3 to the 1, 3 squared, 3 cubed, and so on down the line. But non-positional notation is, let's take Roman numerals. You just have certain symbols for certain numbers, and depending on where they are, if a smaller one comes after a large number, you subtract it. If a larger one comes after a smaller one, you don't. So let's take Roman numerals, for example. L equals 1, 1 equals 1, X equals 5, and then so on. Until you get like M, and so on. So positional is where is like this, where you have b to the 0th, b to the 1, b squared, b cubed. And non-positional is just where you have certain symbols for certain numbers, and then if a larger one comes after a smaller one, you add. If not, you subtract. That's positional versus non-positional. What about bijective versus bijective? I can actually type. So bijective bases versus non-bijectives. What does bijective even mean? For a good example, I like to use balanced ternary. So you can have -4, -3, -2, -1, 0, 1, 2, 3, and 4. So balanced ternary. Instead of using 0, 1, and 2, uses -1, 0, and 1. Non-bijective is sort of the opposite of that. Instead of, so bijective means you're moving it around. You still have 3. You still have 1, 2, 3 for balanced ternary, but you moved it around. So regular ternary, so bijective ternary, also known as balanced ternary, is -1, 0, and 1. But non-bijective ternary, also known as regular ternary, is 0, 1, and 2. And if you are making a base, you don't even need a base at all. You can just give a separate symbol and a separate word for each number. You could just give separate symbols, separate words for each number. You can also have varying bases. You can have X for here, XY here, XY, Z here, X, Y, Z, W, and so on. So you have X, XY, XYZ, XYW, XYU, XYV, XYZ, W, U, V, and so on. You also have, there's also different words for different things. Let's take short versus long. So, for short, so you start with million, and then 10 million, 100 million, 1,000 million, aka billion, 10 billion, 100 million, 1,000 billion, aka a trillion, 10 trillion, 100 trillion, 1,000 trillion, aka a quadrillion, and so on. But for long, you have 1 million, 100 million, 1,000 million, 100 million. So you have 1 million, 10 million, 100 billion, 1,000 million, and then 10,000 million, aka a billion, 10 billion, 100 million, billion, 1,000 billion, 10,000 billion, aka a trillion, 10 trillion, 100 trillion, 1,000 trillion, 10,000 trillion, aka a quadrillion, and so on down the line. And people in Britain will argue, the younger generations will argue that shorthand is the norm, but long will be argued by the older generations on being the norm, because they did a sun switch back then. You can also do what Japanese does and go with one, 10, 100, 1,000, 10,000, so forth, and I shouldn't say so forth, because 100,000, and then you just start doing 1,000 after that. 1 million, 10 million, 100 million, 1,000 million. I should probably add a comma there. 1 billion, and so on. So after 100,000, you just start going 1,000 up for each new comma, 1,000 after 10,000. Yeah, those are some cool and fun things you can do with bases. If I do find more things, I will make a part 2. But for now, bye. But before that, I have some announcements I'd like to make. Announcements. So if you are watching this video, then you've probably seen I have changed my username and my pretty much everything. Yes, I did, because it's Chromium and the thumbnail. I could not pass up on that. I could not pass up on that pun. And 2, most likely in my next video, I will actually start including animation, so you won't have to look at a boring white screen for half of the video while I'm fumbling around trying to delete things. So that's cool. Those are some announcements. Bye.